I am A. Pradeep, working as a assistant professor in the Department of Electrical and Electronics Engineering. So today we are going to discuss about power electronics. So in the power electronics, the basics is for semiconductor devices. So because the power electronics is generated from the basics of the PN junctions, that is a power semiconductor devices. So before we are going to enter the power semiconductor devices, first we should know what is the origin of the electrical engineering. So the electrical engineering is under the category of the three fields. The one is for electronics, the second is power, and the third one is for control. So all the combined the three fields we have to define as this is the electrical engineering. So here we have to mention what is mean for electronics. So the electronics is mean for the electronics is defined from the basics of the semiconductor devices. That means that all the electronic components is operated, it's a very low level of the voltages, that is mean for electronics. So that kind of the components are used in the circuits, so that is the electronic components, it's a very low power voltage level. Then next is mean for we have to move on for the higher level of the voltages. So that is mean for power. So the power will be generated from the generation station, then transmitted from the generation station to the distribution station, and we have to utilize. So that kind of the voltage level we are used for as a power. So that is the power is being for a generation, transmission and distribution of electrical energy. Then the third part is for us a important one, that is for us a control. So the first is mean for we have defined the circuits by using the electronics components. After that we have to use it for us a voltage level by using the power generation stations and transmission and distribution. Then the both will be as a controlled by using the control circuits. So these control circuits we have to majorly we can say is for us a steady state and dynamic analysis. Steady state is mean for us the constant one, and the dynamic means for us it's a day by the real time it will be as a changes. Okay, whatever the changes in your input, then output also will be as a changes. So the both will be as a controlled by using the control circuits with as a closed loop systems. Okay, so this is the basics of the electrical engineering origin. So then why we go for the power electronics, that means, so we have to mention what is the advantages of the power electronics. So one is for a high efficiency. So if you are operating at a low level voltage with the electronic components, you will receive for us a very low level of the efficiency. The same electronic components you have to operate with high power voltages, you will receive for us a high level, high efficiency, and also you will operate it for us the highest level of the voltage appliances. Then next is for us a fast responses. So fast responses means, so if you are operating the highest voltage means, that is means day by day we are utilizing the highest power voltage level. So if you are operating the same voltage into your circuit, so the operation also will be as a high, because you can operating the highest level of the voltages. So the components also will be as a designed for as a highest level of the voltages. So you can receive as a fast response. Then long life. Long life means you can generate it as a AC high level of voltage, that is a AC. So definitely it will be as a continued with your long life. So that is your components also will be as a long life. Then next, high reliability, then small size. So if you are operating as a highest voltages, your compact of your size also will be as a reduced. Then flexibility in operation. So these are the few of the main advantages in a power electronics. Then, so what is the definition of the power electronics? So the power electronics is a applied in a electronics components and conversion, and also will be as a control. So that is mean for us a power electronics. So it states that electronics applied to conversion and control of the electric power. Okay. So, this is a small example. So, you can apply the millivolt. The millivolt will be converted into as a megawatt and also will be as a gigawatts. Okay. So, this is the conversion and control of the power electronics. So, this is the basic structure of the power electronics structure. So, the power electronics structure, so you can use it for as a power converter is our main motive. So, that is means for semiconductor devices we are used. Then input power you are giving to the particular converter and you will receive for as a power output. So, these converter will be act as a conversion from one form to the another form. Then this is for as a controller. So, already I have mentioned this power electronics is mean for as a conversion and control of the electrical power. So, this converter will be used for to conversion and the controller is used for to the control. So, here this one is for as a feedback. So, if you are going for as a controller, we can get it from a output link to the your controller and we have to give to the your input side. So, this is for as a your controller. Okay. Then next. So, what is the conversion? So, we are mentioned for as a this is the converter, that is a power converter. That converter will be as a convert operation will be happened. So, what is the conversion method? So, normally we have for as a two types of the electric power. One is for as a direct current and alternating current. So, this direct current will be converted into as a magnitude. Okay, in your DC we have to convert it only in terms of the magnitude only. Then AC circuits is a possible you have to convert it into as a magnitude, frequency and the number of phases. So, this is a conversion is possible in a AC methods and also for as a DC methods. Then next, what is the classification of the converters? So, the power electronics we are using for as a two types of the supplies. So, it is possible you have to convert from one form to the another form. One is for as a so for this section we have to what we have to given and this section is mean for us what we have to convert. So, first one is for us AC. From the AC supply you have to convert it into as a DC supply. So, that kind of the converter we have to represent as a AC to DC converter. So, what is the another name representation is for as a rectifier. So, here the same the AC supply again we have to convert it into as a AC supply, that is a AC to AC converter. So, these AC to AC converter again we have for us some classification. One is a fixed frequency, that is a AC controller. It is a variable frequency, that is for us a cyclo converter or a frequency converter. So, these two types of the converter under the giving as a input for as a AC. Then next we will go for as a input of the your DC supply. So, first we have to convert DC to DC. So, that is a DC to DC converter. That DC to DC converter we have to represent as for as a chopper. Then next the same DC input, then we will receive for as a AC output. So, that is a DC to AC converter, that is a inverter. Okay. So, this is a simple conversion table for power electronics converter. So, it is this section for input and this section for as a output. Then next, so why we are go for as a power electronics? So, where we can use it these kind of the power electronics components. So, the power electronics components is used for us in all kind of the disciplinary nature. Okay. So, this is a representation for the interdisciplinary nature. So, we have to classify it into as a three divisions. One is for as a electronics, control and power. So, in electronics we have to mention for us to create the circuits by using the devices, that is a semiconductor devices. Then power, we have to get it the power from your static or rotating power equipment. Then the third one is for us a control, that is a continuous or a discrete control. So the three will be as a combined in a one power electronics component. Then next, what is the relationship with your multidisciplinary domains? So the power electronics is used in all kind of the disciplinaries. So example for the power electronics is used in a signal processing, then simulation computing, then solid state physics, electromagnetics, power system, electric machines, circuit theory. So these power electronics is combined with all the multidisciplinary sections. So without the power electronics, we can't run as any disciplinary. Okay, so this is the relationship with the multidisciplines. Then this is the history. So already we know that the different types of the histories. So we can move on. Okay, so then what is the applications? So where we have to use it for these power electronics applications. So the application, all kind of the applications we have used your power electronics. So one is for us industrial applications, transportations, utility systems, power supplies for all kind of the electronic equipment, residential and home appliances, then space technology and other applications. So first we can use it for as a power electronics in industrial applications. So industrial applications you can run all the drives by using in the power electronics sector. So this is a motor drives, electrolyzers, electroplating, induction heating, welding, arc furnaces and lighting. So in all kind of the industrial purpose we are using the power electronics components. Then transportation. So the transportation is used for the trains and locomotives, subways, trolley buses. So in all kind of the transportations we are using the power electronics. Then utility system. So utility system is, so we have to generate the power and we have to use it. So what is the interrelation between the generation station and the distribution side. So on all kind of the utility systems we have to use it. Then next is for us a power supply for the electronic components. So in electronic components also we have used. So what are the few electronic components is for us telecommunications, computers, then office equipments like that. Then residential and home appliances, so lighting, heating, air conditioner, cooking, cleaning, in all kind of the home appliances we are used. Then space technologies. So in the space also we can't get it the power in the space. So we have to go for as a battery. So the battery also is designed by using the power electronics components. So there is a space power systems, satellite power systems, then space vehicle power systems. Then other applications, the nuclear reactors, then environmental engineering. So in all kind of the disciplinaries we can use for the all power electronics components.